Children, here is a daily practice questions and answer for you. It is a physics part. These are the questions from the DDP office, Kolar. Here you observe 4 alternatives are given for each of the following questions. Choose the correct alternative and write the complete answer along with its letter of alphabet. And there are 3 questions. They are the multiple choice questions. Each carry 1 marks, totally 3 marks. So consider the first question. An important difference between alternative generators and direct generators. An important difference between alternative generators and direct generators. You know that alternative generator generates alternating current and direct generator generates direct current. Then what is the difference between them? The main difference is here the first option. The alternative generator has an electromagnet but the direct generator has a permanent magnet. This option is not correct. And B, direct generators have high potential difference. This is also not suitable answer. C, alternative generators have high potential difference. This is also not suitable answer. D, alternative generators have split rings and direct generators have commutator. So in the direct generators, the direction of the current in the external circuit changes for every half cycle, that is with the help of the commutator. So alternative generators are not having the commutative, they are having split rings, and direct generators are having slip rings which are called commutators. So the answer is D. Option D is the answer. So you write that option D answer. Option D, alternative generators are having alternative generators have split rings and direct generators have commutators. Direct generators have commutator. That is option D is the answer. So here the suitable answer is D. Next question. Second question. A person wants to burn a paper without using matchbox and lighter. Which type of lens can be used for this purpose? So the first option is biconcave lens. Second one is B, convex lens. Third, concave lens. All the above. You know that convex lens is the converging lens which converges all the refracted ray at a point. So here the convex lens is which can be used for the purpose of burning a paper. So write the answer B. Answer is that is convex lens. Then next to take third question. The SI unit of resistance is. So what is the SI unit of resistance? You know that is ohm. Here option C is there. What are the 4 options here? Ohm meter, ampere, ohm, volt. You know that ohm meter is the SI unit of resistivity, ampere is the unit of electric current, and ohm is the unit of resistance, and volt is the unit of potential difference. So what is the answer? Answer is C, ohm. That is the unit of SI unit of resistance. So right answer C, ohm. That is the SI unit of resistance. Then fourth question. Here you know that multiple choice questions are over. Then the second main question, short answer type question. There are only 2 questions, each carries 1 marks, total marks 2. Then the fourth question, power of a lens is plus 2.0 D. What does it mean? Here plus 2.D, D means that is a unit of power of lens diopter. And the power of lens is plus 2.0 D. What does it mean? The power of lens is plus 2.0. It means the lens is convex lens. Here it shows positive. So it shows the lens is convex lens. And what is the focal length of this lens? That is, here you know that the relation between the F and D, focal length and power, is D equals 1 by F and F equals 1 by D. So that is 1 by 2, that equals 0.50 meter. That is plus 0.50 meter. That is the focal length of that lens is 0.50 meter. So opticians prescribe corrective lenses indicating their powers. You know what is power? The SI unit of power of lens is diopter, and it is denoted by the letter D. And what is the power of the lens? It is the ability of a lens to converge or diverge light rays, depends on its focal length. So here a convex lens of short focal length bends the light rays through large angles by focusing them closer to the optical center, and the concave lens of very short focal length causes higher divergence than the one with the longer focal length. So the degree of convergence or divergence of light rays achieved by lens is expressed in terms of its power. The power of a lens is defined as the reciprocal of its focal length, and the power is denoted by the letter P, and the unit is diopter, and the symbol of the unit is D. So let us write that power of a lens is 2.0 D. 2.0 D. It means the lens is convex lens. The lens is convex lens because it is positive, as it is positive. And what is its focal length? You know that F equals 1 by D equals 1 by 2.0, that equals 0.5 meter. 0.5 meter. So here what you can say about this, it is a convex lens and its focal length is 0.5 meter. Next to take, what is the reason for refraction of light? Reason for the refraction of light. You know that refraction of light takes place when light travels from one medium to another medium. Light travels with different speeds in different medium. The bending or refraction of light occurs due to the change in the speed of light as it passes from one medium to another medium. So you write reason for refraction of light. Refraction of light. Light travels with different speeds in different media, right? Light travels with different speeds in different media, the refraction of light occurs refraction means that is nothing but bending of light occurs due to the change in the speed of light due to the change in the speed of light as it passes from one medium to another medium. One medium to another medium. Next, the sixth question, that is 2 marks question. Draw a ray diagram of image formed when an object is placed at infinity of a convex lens. Children, go through the video of ray diagram and you go through the first video of the ray diagram of image formed, that is when the object is placed at infinity. You know that when the object is placed at infinity, you will get the image at the principal focus. All the parallel rays from the object enters into the lens, refracts, and the refracted ray passes through the principal focus. So you will get a highly diminished image at the principal focus. You go through the video of ray diagram of image in the object is placed at infinity of a convex lens. Now the question number 7. An electric heater of resistance 8 ohm draws 15 amps current for 2 hours. Calculate the heat developed in the resistor. So here what are given, note down. What is that 8 ohm? That is the resistance R. R equals 8 ohm. Then 15 amps, that is the current I. I equals 15A. And time is 2 hours, time T equals 2 hours, that is 2 into 60 minutes, and also you must convert this into seconds, means 2 into 60 seconds. Then what you have to find out? We have to find out heat. Then let us write heat developed equals the formula you can have I square R into T. I is current, that is 15 square, or you can write 15 into 15. R is 8. T is 2 into 60. Then 15 into 15 into, so write 15 square means 15 into 15, that is 225, and 8 to the 16. 8 to the 16 into 6 the 36, 00. Then you multiply 225 into 16. 16 5 is 80. 16 to the 32. 32 plus 8, 40. 16 to the 32. 32 plus 4, 36. So you got 3600 into 3600. Then 36 into 36 you write. That is Let us take zeros afterwards. 6 6 is 36, 6 3 is 18 plus 3, 201, 216 plus 6 3 is 18, 3 3 is 9 plus 1, 10. You will get 1296,0000 joules. So you can convert that joules into kilojoules, dividing that by 1000. That equals, you can write 1296 into 10 power 4 joules. And also you can convert it into kilojoules if it is divided by 1000, or otherwise you write it as. Question number 8. Why alloys are used rather than pure metals in heating devices? Here you can answer that as compared to pure metals, alloys have higher resistivity. When a current is passed through the element made of alloy, a large amount of heat is produced. Resistivity of an alloy almost does not change with temperature. So an element of alloy does not readily get oxidized at high temperature. Therefore, alloys are used rather than pure metals in heating devices. So you write that as compared to pure metals, as compared to pure metals, alloys have higher resistivity. Alloys have higher resistivity. When a current is passed through, when a current is passed through the element made of alloy, the element made of alloy, a large amount of heat is produced. A large amount of heat is produced. Resistivity of an alloy almost does not change. Resistivity of an alloy almost does not change. Almost does not change with temperature. With temperature. So an element of alloy, so an element of alloy does not readily get oxidized, does not readily get oxidized at high temperature. At high temperature. Therefore, alloys are used rather than pure metals in heating devices. Alloys are used rather than pure metal in heating devices. Now come to the 3 marks question, 9th question. Write the diagram indicating the field lines of a magnetic field around a straight conducting wire and label the following parts. First, plug key. Second, battery. Children, it is a diagram indicating the field lines of a magnetic field around a straight conducting wire. Here the plug key is, this is the plug key. And what is the battery? This is the battery. Draw a neat label diagram to show the field lines of magnetic field around a straight conducting wire. This is the pattern of magnetic field lines around a straight conducting wire. Now this is the 10th question. Explain the relation between these two pairs of words with respect to lenses. First one is focal length and center of curvature. Second, focal length and power of lens. Third, magnification of a lens and height of image and height of object and image. So focal length and center of curvature. You know that focal length is the half of the center of curvature. And focal length and power of lens. Power of lens is the reciprocal of focal length, or focal length is the reciprocal of power of lens. And magnification of lens and height of object and image. So that is magnification equals height of image by height of object. Focal length and radius of curvature. Focal length and radius of curvature. You know that focal length is the half of the radius of curvature, or radius of curvature is the double of the focal length. So you write focal length equals radius of curvature divided by 2. That you can write F equals R by 2. F equals R by 2. That is radius of curvature is twice of the whole length. Or you write R is equals to 2F. R is equals to 2F. Radius of curvature is twice of the focal length. Next one is the relation between focal length and power of lens. You know that focal length is the reciprocal of power of lens, or power of lens is the reciprocal of focal length. So write power of lens equals 1 by focal length, or focal length equals 1 by power of lens. So you can write P, power of lens, equals 1 by F, or F equals 1 by P. Symbolically you can write like this way, and that is the relation, this one. That is the relation between the power of lens and focal length, or focal length and power of lens. That is power of lens. The next one is magnification of a lens and height of object and image. Then you write C, magnification of lens equals height of the image by height of the object. Also you can write M equals H dash by H, where H dash is the height of the image and H is the height of the object, and m is the magnification. That is the relation you can write. Differentiate between real and virtual image. Now let us write the differences between real image and virtual image. So you write our question, first one, differences between real image and virtual image. Real image and virtual image. So you write two columns. One is for real image, and the other is for virtual image. So let us write first one, how the real image forms. Real image forms the actual intersection of the refracted rays. So we write rays actually meet at the image point. So in real image, the refracted rays actually meet at the image point. So write first one, rays actually meet at the image point. Meet at the image point. Here the rays appear to diverge from the image point. Rays appear to diverge from the image point. Then second one, you know that real image can be caught on the screen. Real image can be caught on the screen, but virtual image cannot be caught on the screen. So you write that virtual image cannot be caught on the screen. Then next you take, you know that real images are always inverted images. So take real image is always inverted, but the virtual image is always erect. Virtual image is always erect. These are the differences between real images and virtual images. So rays actually meet at the image point in the case of real image. In the case of virtual image, rays appears to diverge from the image point, and in the case of real image can be caught on the screen and virtual image cannot be caught on the screen. Real image is always inverted, virtual image is always erect. Now the 11th question, explain the environmental consequences of the increasing demand for energy. What measures would you suggest to reduce energy consumption? So explain environmental consequences of the increasing demand for energy. No matter what source of energy is used, increasing demand would disturb the environment in some way or the other. Either it would cause more pollution or cause environmental damage. Development and consumption of energy would go together. Therefore, we should concentrate more on finding better and alternative sources of energy. When looking for alternative sources of the energy, we must keep some point in our mind. So, ease and cost of extracting energy from the source, the efficiency of the available technology, environmental impact of using that source. So, let us write here: increasing demand would increasing demand for energy would disturb the environment. Disturb the environment in some way or the other. In some way or the other. Either it would cause either it would cause either it would cause more pollution or cause environmental damage or cause environmental damage. Development and consumption of energy development and consumption of energy consumption of energy would go together would go together. Therefore, we should concentrate more on we should concentrate more on finding better and alternative sources of energy. More on finding better and alternative sources of energy. When looking for alternative sources, when looking for alternative sources, the following points should be kept in mind. The following points should be kept in mind. Kept in mind. First one, ease and cost of extracting energy from the source. Ease and cost of extracting energy from the source. Second, the efficiency of the available technology. Efficiency of the available technology. Efficiency of the available technology. Third one, environmental impact of using that source. Environmental impact of using that source. Using that source. That is the points should be kept in our mind while looking for different alternative sources. Now the fifth main question, answer the following questions. These two questions are there. They are 4 marks questions. 4 marks questions, 2 questions are there, and total marks is 8. And that is the 12th question. Here A and B sub questions are there, and it is a choice question, and also there is OR question. So what is that 12th question? A, direct current and alternating current. Direct current and alternating current. Which of these most useful? Why? Here DC and AC. Among DC and AC, which is most useful and why? We have to answer. And B, what precautionary measures should be taken to avoid overload caused by home electrical circuits? B question is, what precautionary measures should be taken to avoid overload caused by home electrical circuits? So let us try to answer these A and B questions. First you take A. So you write the answer, alternating current. Alternate current or alternating current is most useful. Among direct current and alternating current, which is most useful? Alternating current is most useful because of the following advantages. Because of its following advantages. So you write first one, the generation of AC is more economical than DC. You write the reason that the generation of alternating current is more economical than direct current. Then also you write second one, the alternating voltage can be easily stepped up or stepped down by using transformer. The alternating voltage can be easily stepped up easily stepped up and stepped down and stepped down by using transformer. By using transformer. Then third one, the alternating current can be transmitted to distant places without any significant line loss. The alternating currents can be transmitted to distant places without any significant line loss. Significant line loss. So here alternating current is most useful because of the following advantages. So generation is economical and you can easily step up and step down, and it can be transmitted to distant places without any significant line loss. Now let us answer to the B question. Precautionary measures should be taken to avoid overload caused by home electrical circuit are as follows. First one, in any part of the house, all appliances are to be connected in parallel to each other across the live and neutral wires. Write that in any part of the house, in any part of the house, all appliances must be connected in parallel to each other across the live and neutral wires. Across the live and neutral wires. Live and neutral wires. And next, two separate circuits are to be used. Two separate circuits are to be used. One of 15 amps for higher rate appliances, for higher power rate appliances, and the other for other for 5 amps. Retake other of 5 amps for low power rating appliances. The next, fuse must be connected in series with the live wire. So you take, fuse must be connected in series with live wire. Fuse must be connected in series with live wire. Now the question, write the construction and function of the electric motor. You can write the answer for this question, that is in the textbook. Children, it is a figure of the electric motor. Now let us discuss about the construction and function of the electric motor. Now let us discuss about the construction and function of electric motor. Now you take the construction first. An electric motor consists of the following main parts. An electric motor consists of the following main parts. First one is field magnet. It is a strong horseshoe type magnet with concave poles. It is a strong horseshoe type magnet with concave planes. So first main part is field magnet. It is a strong horseshoe type magnet with concave planes. Second, armature. It is a rectangular coil. Rectangular coil ABCD having a large number of thin insulated copper wire, thin insulated copper wire wound over a soft iron core. Wound over a soft iron core. The armature is placed between the poles of the field magnet. And it can be rotated about an axis, and it can be rotated about an axis perpendicular to the magnetic field lines. Perpendicular to the magnetic field lines. And the third part, split ring commutator. Third one you take split ring commutator. It consists of a cylindrical metal ring split into two holes, S1 and S2. So you write split ring commutator. It consists of a cylindrical metal ring. It consists of a cylindrical metal ring split into two holes, split in two holes P and Q. P and Q. The two ends A and D of the armature coil are connected to the split rings P and Q. Next you take brushes. Two graphite or flexible metal rods maintain a sliding contact with split rings P and Q alternately. So brushes, you write two graphite or flexible metals. Two graphite or flexible metal rods X and Y you take, maintain a sliding contact with split rings P and Q. Next let us write the function here. Function of the electric motor. Current in the coil ABCD enters from the source battery through conducting brush conducting brush X and flows back to the battery through brush Y and flows back to the battery through brush Y. Notice that the current in the arm AB of the coil flows from A to B. In an arm CD, it flows from C to D, that is opposite to the direction of current through arm AB. That is opposite to the direction of current through arm AB. On applying Fleming's left-hand rule for the direction of force on a current carrying conductor in a magnetic field, we find that the force acting on arm AB pushes it downward. So write, according to Fleming's left-hand rule, for the direction of current, or you write, according to Fleming's left-hand rule, the force acting on arm AB pushes it upward Thus the coil and the axle mounted free to turn about an axis rotate anti-clockwise. So write, thus the coil and axle turn about an axis, or you write, rotate anti-clockwise. At half rotation, Q contacts with brush X. Q makes contact with brush X. And P with Y. The current in the coil gets reversed and flows along DCBA. Current along the coil reversing along the path reversed end flows along the path DCBA. The reversal of current also reverses the direction of force acting on the two arms A, B and C. So, the forces acting on the two arms AB and CD reverses. Thus, AB pushed down is now pushed up here. Thus, here what happens? AB is now pushed up and CD pushed down. The coil and the axle rotate half a turn more in the same direction. Thus, the coil and axle rotate half a turn more in the same direction. Rotate half a turn more in the same direction. So, the reversing of current reverses the direction of the flow of current in the armature and the coil will be in the continuous rotation. Commutator reverses the direction of current and the coil will be in the continuous rotation. This is the function. Now the 13th question, that is also 4 marks question. So here there are 2 sub questions. The first question is, observe the following table. Which of the material can be used for transmission of electricity, heating material and insulator, and why? Here we have to give the reason also. And A is a material with the resistivity 1.62 into 10 power minus 8. And B is a material with resistivity 100 into 10 power minus 6 ohm meter. And C is a material with resistivity 1 into 10 power 10 ohm meter. Here we have to choose the material for transmission of electricity, heating material and insulator. You know that for the transmission of electricity we have to choose the conductor which is a good conductor. You know that as the resistivity decreases, conductivity increases. Metals and their alloys have a low resistivity in the range of 10 power minus 8 ohm meter to 10 power minus 6. They are known as good conductors of electricity. They offer very low resistance to the flow of current. So here you know that if you compare all this, you know that this one is having lowest resistivity. So as the resistivity is minimum, you can consider that this material A is a good conductor of electricity which can be used for the transmission of electricity. So first you write the answer. Here you write material A can be used for transmission of electricity. Transmission of electricity because as the resistivity decreases, conductivity increases. Material A is having lowest resistivity among three. Therefore, it is used for transmission of electricity. The next one, here you know that heating material and insulator. For heating material, it should have moderate resistivity. You know that as the resistivity increases, heating effect also increases. But if it is having maximum resistivity, it will not allow the flow of electric current, flow of electricity, but that can be used as a heating material. But the material which is having maximum resistivity, the substance which have large resistivity more than 10 power 4 ohm, acts as a insulator. Therefore, you can consider the material C is a good insulator. It can be used for insulator. So the material B is having moderate resistivity which can be used as a heating material. So you write that material B is used as a heating material and material C is used as a insulator. So write material B is used for heating material. It is a heating material as its resistivity is higher. resistivity is higher to produce large amount of heat. Large amount of heat. Next, for insulator. Normally the material C is having maximum resistivity. So you know that the insulators are the substance which have large resistivity, that is more than 10 power 4 ohm meter. More than 10 power 4 ohm meter. So this material C is having more than 10 power 4 ohm meter, that is here it is about 1 into 10 power 10 ohm meter. So you can consider the material C is used for insulator. So you write third one, material C is used for insulator. So insulators are the substance because the substances having more than 10 power 4 ohm meter resistivity are good insulators. The next question, second sub question of the 13th question. How does the resistance of a conductor vary with its length? You know that as the length increases, resistance of a conductor also increases. As the length of the conductor increases, the resistance of a conductor also increases. So the resistance of a conductor is directly proportional to its length L. That is, R is proportional to L. So you write that second sub question. Resistance of a conductor is directly proportional to its length. Directly proportional to its length, that you can say length L. That is, R is proportional to L. It means as the length increases, resistance also increases. As the length decreases, resistance also decreases. That means as length of a conductor increases, its resistance also increases. As the length of a conductor decreases, its resistance also decreases. decreases. That is the answer for the last question, second part.